Hello students, welcome to this lecture, one introduction to trigonometry and its application. Okay, so in this lecture, we will discuss NCERT Exemplar problem, one introduction to trigonometry and its application. Okay, so let's get started. So in this question, here we have if cosec theta plus cot theta is equal to P, then we have to prove that cos theta is equal to P square minus 1 divided by P square plus 1. Okay, so let us prove this problem. So we have basically cosec theta plus cot theta is equal to P. So here first of all we see thinking process. So how to think this problem? So reduce the given equation into sine theta and cos theta and simplify. Okay, and in simplification form we use the Campanero and dividendo rule to get the desired result. So given that cosec theta plus cot theta, this is equal to P. Okay, so we know cosec theta, this is equal to 1 by sine theta, and cot theta, this is equal to cos theta by sine theta. Okay, so if we use this two formula, then we'll get this is equal to cosec theta plus cot theta is equal to P. It implies 1 by sine theta plus cos theta by sine theta is equal to P, and it implies 1 plus cos theta by sine theta is equal to P by 1, and it implies 1 plus cos theta whole square by sine square theta is equal to P square by 1. Basically here we take square 1 both sides. Okay, and it implies 1 plus cos square theta plus 2 cos theta by sine square theta is equal to P square by 1. Okay, so here using Campanero and dividendo rule, we get 1 plus cos square theta plus 2 cos theta minus sine square theta divided by 1 plus cos square theta plus 2 cos theta plus sine square theta. This is equal to P square minus 1 divided by P square plus 1. Okay, and it implies 1 plus cos square theta plus 2 cos theta minus 1 minus cos square theta divided by 1 plus 2 cos theta plus cos square theta plus sine square theta. This is equal to P square minus 1 divided by P square plus 1. Okay, and we know this formula cos square theta plus sine square theta is equal to 1. Okay, so now if we put this value in this formula, then we'll get 1 plus 2 cos square theta plus 2 cos theta divided by 2 plus 2 cos theta. This is equal to P square minus 1 divided by P square plus 1, and it implies 2 cos theta times cos theta plus 1 divided by 2 times cos theta plus 1. This is equal to P square minus 1 divided P square plus 1. Okay, therefore cos theta here cos theta plus 1 and cos theta plus 1 and 2 will cancel, and we get cos theta. So therefore cos theta is equal to P square minus 1 divided by P square plus 1. Okay, hence proved. Now let us move to next problem. So in next problem, here we have to prove that we have to prove that square root of sec square theta plus cosec square theta, this is equal to tan theta plus cot theta. Okay, so let us prove this problem. So here left hand side, this is equal to square root of sec square theta plus cosec square theta. Okay, and we know sec theta is equal to 1 by cos theta, and cosec theta this is equal to 1 by sine theta. Okay, so this is equal to square root of 1 by cos square theta plus 1 by sine square theta. Okay, and this is equal to square root of sine square theta plus cos square theta divided by sine square theta into cos square theta. Okay, and this is equal to square root of 1 by sine square theta into cos square theta. Since sine square theta plus cos square theta is equal to 1, okay, and this is equal to 1 by sine theta into cos theta, and we know sine square theta plus cos square theta, this is equal to 1. Okay, so now if we put in 1, if we replace 1 with sine square theta plus cos square theta, then we'll get this is equal to sine square theta plus cos square theta divided by sine theta into cos theta. Okay, and this is equal to sine square theta by sine theta cos theta plus cos square theta by sine theta cos theta, and this is equal to sine theta by cos theta plus cos theta by sine theta, and this is equal to tan theta plus cot theta, and this is actually our right hand side. Okay, so left hand side is equal to right hand side. So hence proved. Hence proved square root of sec square theta plus cosec square theta this is equal to tan theta plus cot theta. Okay, so now let us move to next problem. So in next problem, here we have the angle of elevation of the top of a tower from certain point is 30 degree. If the observer moves 20 meter towards the tower, the angle of elevation of the top increases by 15 degree. Then find the height of the tower. Okay, so let us find the height of the tower. So first of all, we'll see thinking process. So in first we drawn a right angle triangle from the given information in the question. Okay, and second, now apply the suitable trigonometric ratio corresponding to given sides in the triangle and get the required value of which we want. Okay, so let us find. So let the height of the tower be h. Okay, and also given that given that in this triangle PQR, in this tan theta, this is in this triangle PQR, sorry, this in this triangle PSR, in this triangle PSR, here tan theta, this is equal to PR by SR, and this is equal to H by X. Okay, and it implies tan theta, this is equal to H by X, and it implies X is equal to H by tan theta. Okay, naming this equation number 1, and now from this triangle PQR. So this is also a right angle triangle, since at angle R this is 90 degree. Okay, so angle R is 90 degree, so this is a right angle triangle. Okay, so PQR triangle PQR, here tan 30 degree, this is equal to PR divided by QR, and this is equal to PR by QR plus QS plus SR. Okay, and it implies tan 30 degree is equal to H by 20 plus X, and it implies 20 plus X, this is equal to H by tan 30 degree. Okay, and we know tan 30 degree is equal to 1 by root 3. Okay, so 20 plus X, this is equal to H by 1 by root 3, and it implies 20 plus X, this is equal to H times root 3. Okay, so it implies 20 plus X is equal to H times root 3, and it implies 20 plus H by tan theta, this is equal to H times root 3. So naming this equation 2, and from equation 1, here since after moving 20 meters towards the tower, the angle of elevation of the top increases by 15 degree. Okay, that is angle PSR, this is equal to theta, and this is equal to angle PQR plus 15 degree. Okay, so it implies theta is equal to 30 degree plus 15 degree, that is equal to 45 degree. Okay, therefore 2 plus H by tan 45 degree, this is equal to H times root 3. Okay, and it implies 2 plus H by 1, this is equal to H times root 3, and it implies 20 is equal to H root 3 minus H, and it implies H is equal to 20 by root 3 minus 1. Okay, and now rationalize it, then we will get H is equal to 20 by root 3 minus 1 times root 3 plus 1 divided by root 3 plus 1. Okay, by rationalization, so it implies H is equal to 20 times root 3 plus 1 divided by 3 minus 1. Okay, and this is equal to 20 times root 3 plus 1 divided by 2, and this is equal to 10 times root 3 plus 1 meter. Okay, so the height H is equal to 10 times root 3 plus 1 meter. So hence the required height of the tower is 10 times root 3 plus 1 meter. Okay, now let us see question number 4. So in question number 4, here if 1 plus sin square theta, this is equal to 3 sin theta into cos theta, then prove that tan theta is equal to 1 or 1 by 2. Okay, so let us prove this problem. So here first of all, our thinking process will be, first we reduce the given equation with the help of trigonometric ratio and identities in the form of cot theta. Okay, and then second, now factorize the quadratic equation in cot theta by splitting the middle term and get the desired result. Okay, so here given 1 plus sin square theta, this is equal to 3 sin theta into cos theta, and 1 dividing by sin square theta, 1 both sides, here we get 1 by sin square theta plus 1, this is equal to 3 cot theta. Okay, and since cot theta, this is equal to cos theta by sin theta. Okay, and it implies cosec square theta plus 1. This is equal to 3 cot theta. And we know cosec theta is equal to 1 by sin theta. So it implies 1 plus cot square theta plus 1. This is equal to 3 cot theta. Since we have cos square theta minus cot square theta is equal to 1. Okay. So it implies cot square theta minus 3 cot theta plus 2. This is equal to 0. And by splitting the middle term, here it implies cot square theta minus 2 cot theta minus cot theta plus 2 is equal to 0. Okay. And it implies cot theta times cot theta minus 2 minus 1 times cot theta minus 2. This is equal to 0. Okay. And it implies cot theta minus 2 times cot theta minus 1. This is equal to 0. And it implies cot theta is equal to 1 over 2. Okay. So therefore, tan theta, this is equal to 1 over 1 by 2. Okay. So since we know tan theta is equal to 1 by cot theta. Okay. Hence proved tan theta is equal to 1 or 1 by 2. Now let us move to next problem. So in next problem here if sin theta plus 2 cos theta is equal to 1, then prove that 2 sin theta minus cos theta is equal to 2. Okay. So let us prove it. So here first of all we will see thinking process. So is first of all think squaring both sides the given equation and use the identity sin square theta plus cos square theta is equal to 1 to change the sin square theta into cos square theta and vice versa. And finally use the identity a minus b whole square, that is equal to a square plus b square minus 2ab, and get the desired result. Okay. So you're given that sin theta plus 2 cos theta is equal to 1. And now when squaring both sides, here we get sin theta plus 2 cos theta whole square. This is equal to 1. Okay. And now if we use the identity a plus b whole square, that is equal to a square plus 2ab plus b square. Okay. Then it implies sin square theta plus 4 cos square theta plus 4 sin theta into cos theta is equal to 1. Okay. And it implies 1 minus cos square theta plus 4 times 1 minus sin square theta plus 4 times sin theta into cos theta. This is equal to 1. Since we know sin square theta plus cos square theta is equal to 1. Okay. So it implies minus cos square theta minus 4 sin square theta plus 4 sin theta cos theta. This is equal to minus 4. Okay. And it implies 4 sin square theta plus cos square theta minus 4 sin theta cos theta. This is equal to 4. And it implies 2 sin theta minus cos theta whole square. This is equal to 4. Since we know this identity a square plus b square minus 2ab, this is equal to a minus b whole square. Okay. So it implies 2 sin theta minus cos theta. This is equal to 2. Okay. And hence proved. So hence proved 2 sin theta minus cos theta is equal to 2. And now let us move to next problem. So in next problem here we have the angle of elevation of the top of a tower from 2 points distant S and T from its foot are complementary. Then prove that the height of the tower is square root of ST. Okay. So let us prove this. Let us prove the height of the tower is square root of ST. So first of all, here we'll see how to think about this problem. So here basically use the concept of complementary angles in the angle of elevation. That is, if two angles are complementary to each other, then the sum of both angles is equal to 90 degree. It implies alpha plus beta, this is equal to 90 degree, where alpha is equal to theta and beta is equal to 90 degree minus theta. Okay. So now let us move to solution. So let us see solution. So let the height of the tower be h, and here angle ABC, this is equal to theta. Okay. So now angle of elevation of both positions are complementary. That is, angle APC is equal to now 90 degree minus theta. Okay. So this angle APC is theta, and angle ABC is theta, and angle APC is 90 degree minus theta, since they are complementary angles. Okay. So now if now in triangle ABC, tan theta, this is equal to AB by this is equal to AC by BC. Okay. And this is equal to H by S. This is our small s. So this tan theta is equal to H by small s. And in triangle APC, here tan of 90 degree minus theta, this is equal to AC by PC, and this implies cot theta, this is equal to H by T. Okay, since tan of 90 degree minus theta, this is equal to cot theta, and since cot theta is equal to 1 by tan theta. Okay, so 1 multiplying this equation, this equation, and this equation, and this equation, we get, one multiplying one equation 1 and 2, we get tan theta times 1 by tan theta. This is equal to h by s times h by t. Okay, and it implies h square by st, this is equal to 1. H square by st, this is equal to 1. So it implies h equal to square root of st. Okay, h equal to square root of st. So the required height of the tower is square root of st. Hence proved. Now let us move to next problem. So in next problem, here we have the shadow of a tower standing on a level plane is found to be 50 meter longer when sun's elevation is 30 degree than when it is 60 degree. Find the height of the tower. Okay, so here we need to find the height of the tower. So let us find the height of the tower. So first of all, we'll see thinking process. So we consider the shadow of the tower be x meter when the angle of elevation in that position is 60 degree. Okay, when angle of elevation is 30 degree, then the distance becomes 50 plus x meter. So now we apply suitable trigonometric ratios in the triangle and get the desired result. So first of all, here we let the height of the tower be h and rq, this is equal to x meter. So given that here we have this triangle, okay, SRQ. So in this triangle SRQ, here PR is equal to 50 meter, angle SPQ, this is equal to 30 degree, and angle SRQ, this is equal to 60 degree. Okay, so in this triangle SRQ, yes, tan 60 degree, this is equal to SQ by RQ, and it implies root 3 is equal to h by x, and it implies x is equal to h by root 3. Okay, now in this triangle SPQ, here tan 30 degree is equal to SQ by PQ. Okay, and we can write PQ as PR plus RQ. So this is equal to SQ by PR plus RQ. And here SQ is equal to H. Okay, and PR is equal to 50 and RQ is X. So tan 30 degree is equal to h by 50 plus x. Okay, and we know the value of tan 30 degree, that is equal to 1 by root 3. So it implies 1 by root 3, this is equal to h by 50 plus x. Okay, so it implies root 3 times h is equal to 50 plus x, and it implies root 3 times h is equal to 50 plus h by root 3. So basically we get this from equation 1. So it implies root 3 minus 1 by root 3 times h, this is equal to 50, and it implies 3 minus 1 times h by root 3 is equal to 50, and therefore h is equal to 50 times root 3 by 2. Okay, so h is equal to 25 times root 3 meter. Hence the required height of the tower is 25 times root 3 meter. So let us solve question number 8. So in question number 8, here we have a vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff of height h at a point on the plane. Okay, the angles of elevation of the bottom and the top of the flagstaff are alpha and beta respectively. So prove that the height of the tower is h times tan alpha by tan beta minus tan alpha. Okay, so here let us see the answer. So let the height of the tower be h and OR is equal to x. Okay, so given that height of the flagstaff h is equal to AP and angle PRO this is equal to alpha, angle FRO this is equal to beta. So now in triangle PRO, this is here tan alpha is PO is equal to PA divided by RO, and this is equal to h by x. Okay, and it implies x is equal to h by tan alpha. And in triangle FRO, here tan beta this is equal to FO by RO, and this is equal to FP plus PO divided by RO. Okay, and here tan beta is equal to h plus capital H by x, and it implies x is equal to h plus capital H by tan beta. Okay, so now from equation 1 and 2, here capital H by tan alpha is equal to h small h plus capital H by tan beta. Okay, and by calculation here it implies capital H is equal to h tan alpha by tan beta minus tan alpha. Hence the required height of the tower is h tan alpha by tan beta minus tan alpha. Okay, so now let us see the next problem. So in next problem, if tan alpha plus sec theta is equal to L, then prove that sec theta is equal to L square plus 1 by 2L. Okay, so here basically we have given, first of all, tan theta plus sec theta is equal to L, and multiplying by sec theta minus tan theta, one numerator and denominator left hand side, we get, it implies tan theta plus sec theta into sec theta minus tan theta divided by sec theta minus tan theta is equal to L. Okay, and it implies sec square theta minus tan square theta by sec theta minus tan theta is equal to L. Okay, and here we know this formula, sec square theta minus tan square theta is equal to 1, so it implies 1 by sec theta minus tan theta is equal to L, and it implies sec theta minus tan theta is equal to 1 by L. Okay, and now one adding 1 and 2, equation 1 and 2, we get 2 sec theta is equal to L plus 1 by L. Okay, and sec theta is equal to L square plus 1 by 2L. Okay, hence proved. And now let us see question number 10. So if sin theta plus cos theta is equal to P and sec theta plus cosec theta is equal to Q, then prove that Q times P square minus 1, this is equal to 2P. Okay, so let us see the answer. So firstly, we will get the value of sin theta into cos theta with the help of the given both equation. Okay, and secondly, now squaring both sides of the equation, sin theta plus cos theta is equal to P, and put the value of sin theta into cos theta. Okay, and finally simplify it and get the desired result. So here given that sin theta plus cos theta is P and sec theta plus cosec theta is Q. Okay, so it implies 1 by cos theta plus 1 by sin theta is equal to Q. Okay, and it implies sin theta plus cos theta by sin theta into cos theta is equal to Q. Okay, and it implies P by sin theta into cos theta is equal to Q, and it implies sin theta into cos theta is equal to P by Q. Okay, and sin theta plus cos theta is equal to P, and since sec theta is equal to 1 by cos theta and cosec theta is equal to 1 by sin theta. And now one squaring both sides, we get sin theta plus cos theta whole square, this is equal to P square. Okay, and it implies sin square theta plus cos square theta plus 2 sin theta into cos theta is equal to P square. Since we know this identity A plus B whole square, this is equal to A square plus 2AB plus B square. Okay, and it implies 1 plus 2 sin theta into cos theta is equal to P square, since sin square theta plus cos square theta is equal to 1. Okay, and it implies 1 plus 2 into P by Q is equal to P square. So it implies Q plus 2P is equal to P square Q, and it implies 2P is equal to P square Q minus Q. Okay, and it implies Q times P square minus 1, this is equal to 2P. Okay, so hence proved Q into P square minus 1, this is equal to 2P. So this is all about this lecture. I stop here this lecture. Thank you very much to all of you.